I just wanted to start with a couple of announcements. First of all, raise your hand if you're a member of the International Society for Diatom Research. What?
I used to be.
Yeah. Okay. You should rejoin because there are going to be some really nice scholarships for early career researchers that come out soon. I'm going to put the ISDR website in the chat. And I also posted a news article on diatoms.org about the society because it is really working to serve people on an international level, to bring in folks from developing countries, from students. These new scholarships will be announced. You get diatom research for a pretty bargain price, and that's both an electronic and a paper copy. And I'm gonna be the new president.
What? Congratulations, Sarah.
So that's my plug for the society. I hope you join. And if you join right away, like today, vote for council members that are young and diverse and make an impact on the society, because it's a good place to be able to join together with other diatomists to get things done. Okay, next, I wanted to announce that our next speaker in 2 weeks on October 25th is Stacy Levy, who is an environmental artist, and she's going to be speaking about ecology and art, new ways of seeing the invisible patterns of nature. And she's got some great projects in New York, where she actually looks at the diatom species in the East River and creates public works based on what she sees. So join us for that. And then I'm pleased to introduce Blanca Hinojosa as today's speaker. Blanca got her degree at the University of Houston downtown, and she works as a water quality specialist for Metro Water Recovery. And I met Blanca on this Diatom Web Academy. And so when I saw her put her name up as being a part of this session and working in Denver, I wrote to her and said, "What are you doing? We ought to meet." And we have visited each other's labs, and she gave me and another USGS colleague an incredible tour of the Denver Metro Water Recovery and what happens downstream of our water treatment in this large urban area. So I'm really pleased to have Blanca here, part of our community, to present on her work, proposed project, Diatom Flora of the South Platte River from Denver to Platteville, Colorado. So take it away, Blanca.
Thank you so much, Sarah. I'm really happy to be here to talk about this potential project that I'm working on with Metro Water Recovery. This is just a proposal for looking at the diatom flora of the South Platte River from Denver to Platteville, Colorado. And the project goal is to establish the community diversity within the South Platte segment. And this can be done by this is going to be done by creating a periphyton database, which will also include a diatom database. Currently, we use macroinvertebrates to understand the pollution index within the South Platte. However, as a regulated entity like Metro Water Recovery, we know that using periphyton will potentially become a future methodology, and we'd like to understand how we can use periphyton now before it becomes the future. And so this will let us understand how the biota within our river can help change kind of the future of wastewater treatment, and just kind of understand what kind of story the South Platte in general has to say to us. Oh, I lost controls. Oh, there we go. And so here's a general project idea. And I'd like to sample seasonally for the first 2 years. And this is not typical of how you would normally sample, especially when you're looking at pollution index. You would probably want to sample around midsummer until late fall. But because I'm trying to understand what's already in the river and what exists in the river, sampling seasonally for the first 2 years can give me a robust understanding of the community and the population that exist within the South Platte segment. We'll also be sampling 6 to 9 sites on the South Platte River segment that I'm looking at, which will allow for a smaller reach. I know this is a little up ahead, but I promise I'll help. I'll break it down a little bit later. And so one of the sites that we want to do is we want to do a little bit upstream from the Burlington diversion, kind of in downtown Denver. We want to do a site between right here is Metro Water Recovery's outfalls. And I'd like to do a sample between Metro Water Recovery's outfalls and Burlington's diversion. And then right before Clear Creek confluence comes in, we would like to sample here. And then between Clear Creek confluence and Metro's secondary treatment plant, I would like to get a sample around 128th Avenue. And there might be another sample in there, but I'm not too sure at the moment. And then we would like to, because of the way that because of how we're regulated, we need to look at the river in 2 segments. And so the last sample will be in Platteville, which is way up here after the Platteville wastewater treatment plant. And so with that being said, it'll also we'll also be obtaining the following, which is a qualitative and quantitative diatom index, a qualitative and quantitative periphyton alongside with diatom identification, chlorophyll A, ash-free dry mass, regular water parameters and flow, which is typical for what you want to look at when you're sampling for periphyton. And this information will then be used with a multi-metric indice for future pollution indication, and the diatom identification that I'd like to do with this sampling is the Flora voucher methodology. So who is Metro Water Recovery? Metro Water Recovery is a wastewater treatment plant, which is now known as a water resource recovery. It was formed in 1961 as a response to the human waste problem. And before that, people were just throwing their human waste in the South Platte River. And so it serves approximately 2.2 million people in the Denver metro area, and it treats about 130 million gallons of wastewater every day. And so that's about 80%. So about 80% of the time, Metro Water Recovery's outfalls make up the majority of the South Platte River. And here in this image is our main facility. It's called the Height Facility. And here's the South Platte that runs alongside with it. And here you can see where the outfalls are on the Height Facility leading into the South Platte. And the secondary facility is in Brighton, Colorado, and it treats about 5 million gallons daily. And so for this study, we're going to be looking at both plants. And so here's just a little overall knowledge of the South Platte River. Its headwaters are in the Mosquito Range. It ranges from Fairplay, Colorado to Julesburg, Colorado. It's approximately about 380 miles within Colorado. And you can see how important, as the river goes through the northeastern side of the state, how important that river might be for that part of the state. It looks like it's only like the most major river out there, and it's been a really interesting kind of study for me to look at the South Platte. But for the purpose of the study, we won't be looking at the entire river. That would take me a long time, and I don't have that resources. And so we'll just be looking from downtown Denver until Platteville, Colorado. And this is about 35 miles stretch of the river where Metro discharges into. And as a regulated entity, it's important to kind of understand the impacts of our water system. And however, it's also important to understand other influences that could have impacts to that river. And so that's kind of where periphyting come into play a little bit, and kind of where this study gets a little confusing and maybe even a little challenging, because there are many different things that impact this river that is not just the wastewater treatment discharge. There are many different factors. And just to name a few, we have 11 diversions on the South Platte River. And without mentioning the largest one, we'll talk about, here's Bratner Ditch, which is a water diversion ditch. Here's Fulton Ditch, another water diversion ditch. Here's Brighton, here's Lepton Bottom, here's Platteville, and here's Evans Ditch. And so these are just a few diversions that can extract water from the river that might play an impact on hydrology and biological movement in the river. And then another thing that I have to take into consideration is that this river also has 3 major confluences, and those confluences can impact the river in ways that the wastewater treatment plant discharge may not even be impacting as well. And so Sand Creek, which literally enters a 1/10 of a mile downstream from Metro's discharge, from Metro's main discharge. Clear Creek, which is approximately 1 mile downstream from Metro's outfalls, and Big Dry Creek, which is about 5 miles from the North Treatment Plant's discharges. And so these confluences are still within the river reach that we have to study, but that doesn't mean that they're not influencing the river as well. And so it's really interesting to take these things into consideration when you're looking at, pollution index for the whole river for a particular type of industry. And in this case, the wastewater treatment plant from Metro. And not only that, there's land use that also changes in this segment of the South Platte River, where we start from an incredible urban area, which is an industrial park in the North Denver area. And then we move directly into suburban, and then we move into gravel pit operations, and then we move into concentrated animal feed operations. And these can change the influence in the river. Having these different changes occur can impact the river. And not to mention that drop structures can also influence the river. And drop structures have been put in on the river to kind of increase water quality, which have been really, really good. But then you have something like this. Here in this image is a drop structure, and you can see it right there. You can see how kind of it changes the hydrology, and even would change the biology of this river to add a drop structure. So these are things that I'm trying to kind of consider as I'm considering sites. I'm considering the best area to sample, because this could potentially become the future of pollution index. And if it is the future of pollution index, these are all the factors that we need to take into consideration as we're moving forward. So I talked about diversions, and I didn't mention the largest diversion, and this is the largest diversion that affects the river segment that I look at. This diversion is the Burlington Ditch diversion, and here is a picture of it completely removing almost 100% of the river water and diverting it into farmland or water rights. This is very impactful for us, where there is no water coming from upstream. There is basically very little influence from the original headwaters of the South Platte that move into the metro water recovery river reach. And it's not always like this. Sometimes it doesn't divert completely. Sometimes it diverts just a little bit of water and you still have a little bit of flow coming through. But on days where the water is completely diverted, we can have a really huge biological system failure, kind of. You have no hydrological influence coming from upstream of your river. And here's what you get. This is just shortly upstream of Metro Water Recovery's discharge, where you suddenly have all of the South Platte River being completely diverted into the Burlington Ditch. And you can have things like algae blooms or low DO or water parameters that may not be the same as a river that is upstream from the diversion. And so when I'm looking at this project, some of the questions I have is, well, what is the river and who is the river and where does the river start? And it gets really confusing and convoluted as I think about how Metro is influencing the river. And of course, Metro is influencing the river because we make up most of the river sometimes. You know, like I said earlier, 80% of the time, or we make up about 80% of the river. And here is an outfall. Here are the main facility, Heights facility outfalls, which is about 210 CFS. And you can see how it brings a lot of water back into the river where originally it was being diverted further upstream. It's really important to kind of think about this because sometimes I think, you know, would there even be a river if there was no outfall here? And that's really interesting. And so we definitely look at Metro Water Recovery's outfalls as kind of as kind of becoming the effluent dominant headwater of the South Platte. And so that brings me into a lot of understanding about how difficult the South Platte can be and how difficult the South Platte can be to understand just what I really need to get a good periphyton study to understand the influence of Metro on the river without thinking of any other things. But rivers are biological systems and they're going to change. So that brings me into my next conversation, which is the complications of choosing methodologies. I have been looking at many, many different methodologies. And because we are a regulated entity, it's really important to choose a methodology that we believe could eventually become the regulated methodology. And this is real difficult. I've spent hours, days, weeks, months scouring through everyone's different methodology, trying to see how the South Platte fits within the methodology. And it's really hard to figure out what works best for us. And even though I have a methodology on here from Colorado Department of Public Health and Environment, which is amazing, I sometimes feel that there's a little lacking on the problems that we have. And so just like I said, I did also look at tons of other methodologies out from different states and saw if they were looking at diatoms as well as periphyton and try to see if they had different methodologies to study the type of river that we have, because the sedimentation in our river can go from gravel to sand, and the further you move away from man, the more sandy it becomes. And it's really tough to find another state that kind of understands the complications that a headwater state has. The headwater, being a headwater state here in Colorado makes it really unique. And there's a lot of methodologies that are used to working on really nice, flowing, even distribution rivers. And then the other factor is not a lot of people have really talked about an effluent dominant river and what to do with an effluent dominant river. And how to sample an effluent dominant river and what type of river would it be considered. Anyways, and so this is kind of where I start looking at different methodology to just kind of make sure I sort of attempt to get the best periphyton data. And so one of the potential sampling procedures that I really, really enjoy is USGS. I feel like USGS methodology really breaks down exactly what type of sampling you need to do. It's very good about saying we need to look at the representation of a river. And I understand that as a regulated entity, sometimes we don't do exactly what we're supposed to do. It's why we get stricter and more stringent regulations put on us. However, I really enjoy how USGS breaks down to look at a representation of the river, how to sample, when to sample with what, and what to get everything, what to have. And this picture on the right, by the way, is a little older, but they kind of use the same techniques. They have something really cool to get some gravel samples, which I didn't add here on this image. But if anybody can tell me where you get an SG92, I have scoured the internet and I have no idea. I will never probably sample on gravel that is large enough to use an SG92, but it's a very curious design for me, and I really wanted to see one in person. Anyways, and so moving on, we have the two sampling procedures that I actually really want to focus on because they're most likely going to be something that I look at a little bit closer, is EPA's sampling procedure, CDPHE's sampling procedure. So EPA takes your reach and they're asking you to do your reach as a 40 times mean of your wetted width, which for us is really difficult. It might just be me and one other person out in the river, and to do a whole kilometer of a river would take me all day and probably can be dangerous depending on flows. And so that is why in a previous slide, you saw that we were going to sample multiple parts of the river, and that allows us to have a smaller reach. However, with EPA sampling methodology and there are 11 transects on the reach, you sample one subsample per transect. It says at random, but basically it's whatever you choose, then you do center, left, right, or whatever left, right, center on, however you choose. They talk about how if there is no cobble or larger sediment in the river to confine 12 centimeters squares and back in the top 1 centimeter of sediment, which is kind of similar to what CDPHE's methodology is. But CDPHE's methodologies would prefer that you not section the top sediment and prefer that you find instead some other woody snag or rock or things like that. Some parts of our river might have some of these and some of them won't. They'll just be all soft sandy bottom. And it makes it much more difficult to find these external sources. So CDPHE's method, unlike EPA's, is asking for 5 transects on a wetted width, and they take 5 subsamples within a transect. And this also causes me to question what to do with backwater sampling. Would backwater sampling be considered a representative sample for periphyton in the river, especially if I'm moving more towards a pollution index? And so these are things that I have questions about that I'm probably will find out in the 2 years that I started sampling, to be honest with you, where I'm just looking for a population within the river before actually thinking about moving into a pollution index in the river. And so some of the things I need help understanding while I do this project or in the middle of doing this project is How do the diversions affect the biota within the river? What will give me the taxonomic inventory within this reach? And will sampling confluence help eliminate potential biota influence from the pollution index, which is kind of important. I don't want to say that Metro is responsible for all of this index. It could be that, Sand Creek is responsible or Clear Creek is responsible. And would it be beneficial for an entity, a regulated entity like us to sample those areas just so that we can get a more robust understanding about what we are doing and what we are sampling for. Anyways, that's all I have for today. Thanks so much for listening to me. And if you guys have any questions or comments, I'll take them.
Great. Thank you so much, Blanca. Appreciate this really interesting system where you're working. And since we just have a few people, I'll just invite everyone to turn on your camera and you can raise your hand or just go ahead and make a comment. Just to start things off, one of the things that you didn't talk about, Blanca, was stormwater. And I was just wondering if you have a sense of, sort of extreme events and how they might influence this system in kind of an overwhelming way. That is, everyone might be doing the right thing in terms of discharge in all your different inflows, but having a large storm event with surface of water runoff could introduce all manner of sediments, pollutants, nutrients. And how are you thinking about that? How are you thinking about stormwater influence?
Yeah, so stormwater definitely can bring a lot of added influences to the South Platte, especially because, Metro water recovery is strictly downstream from Denver, and a bunch of little Denver cities right before that. So one of the things that we do here is we sample the river twice a month. And that it doesn't matter what the temperature is or the weather is, and that allows us to kind of give a robust understanding of the stormwater influence that occurs inside of our river. And that's kind of the data that I will be looking at just to see if that is influencing periphyton. We have about 30 plus years of data of looking at the river twice a month. And it would be really good to just kind of understand what stormwater is bringing in. But, like for us, we don't necessarily look at stormwater just on its own. We hope that Denver does that, and so we hope that Denver would share all that information with us so that we know what's actually going in the river. We know what's going in the river from our outfall. We sample our outfalls to know what is entering the river, but we don't. And that's one of the things about this whole idea of sampling a little bit further upstream from the outfalls. It's really important for us to see what's also coming in from that area.
Mm-hmm. Thank you. Anybody else? If people, yeah, go ahead, Layla.
Oh, you're muted.
Oh, it's still on mute. I wonder if you can't, let me see. Are you
Sorry.
Oh, there you go. There you go.
Yes. So I thank you, Blanca. I wanted to ask you if you tried first to just to see the diatom assemblage in calm water, in running water, on sand, on on phytoplankton, just to have an idea about the whole assemblage before to prepare all this protocol of sampling, because maybe it's worth to do so to see if there is very big difference in this kind of assemblage. Have you tried this?
Absolutely. So that's the first 2 years, right? So the first 2 years is us trying to figure out where, how, and why, right? But it would be really interesting. So are you asking, like, instead of doing a combined, instead of doing a composite sample of the combined river reach, are you asking like to sample one site individually?
What I mean, if maybe in some area you need to make a close sampling just because there is a lot of change in the diatom assemblage, and in other area maybe it stayed for long diversion, the same diatom assemblage. I mean, if you make your sampling just the same distance and do not try to see the difference between the assemblage, maybe it's not enough.
Sorry, I'm writing notes.
What I mean, sometimes you can have the same type of assemblage, so you don't need to sample each, I don't know, each 1 kilometer.
Like reach.
Yeah, and sometimes you need to sample each 5 meters, for example, just because you have change either because of the confluence or because of the diversion of because of the drop structure and the running water. I don't know. I wondered if you notice in the diatom, the response of diatom, real distinction.
So this is something that, this is one of the reasons why I really enjoy USGS's method. It is because it kind of says to look at the system and understand the system, and then from there you should be able to just take 5 samples, right? Regardless of how your reach is. Your reach might be small, your reach might be big, but I understand completely on you know, making your reach smaller because you're getting the same type of assemblages. This is a really good idea, and I think in a preliminary study, it would be something that I take into consideration. But I think because the unfortunate truth is we're a regulated entity, sometimes we don't get the luxury of just sampling small little segments of the river. We have to sample the same size segment throughout the river to prove that, you know, we have a comprehensive sample, which is really crazy. And I will say this small little blip here, because sometimes even when we're doing things like fish shocking, where we're sampling a certain reach of the river, half of the river might be really abundant in a few species, and then the other half could be abundant in just 2 species. But we do a composite because we have, as a regulated entity, have said that we're going to look at this big of a river. So it gets really difficult, I think, or I believe that, you know, like to kind of say, I know that the diatom assemblage has not changed. Even in this preliminary study for 2 years, my diatom assemblage has been the same. And therefore I want my river reach to, instead of being, you know, which is not going to be a kilometer, it's going to be most likely 400 meters to 500 meters. You know, maybe I want to just change it to 10 feet and just do the best sampling with what I believe is like good for the habitat. But I don't think we could do that, unfortunately.
Yeah, Blanca, I can just clarify that.
Yeah.
USGS and EPA both specify composite collections. So they are, along whatever that a particular sampling reach,
Right.
is a composite of 11 transects, random sites that all go into the same container. So they are not doing the microhabitat
Right.
of sampling. Yeah, thanks. Anybody else? I have another question, and maybe I've already asked this, Blanca.
It's
but
okay.
I'm still trying to really understand it. Does the river, between the point of this outflow of 130 million gallons of water, that has had its tertiary treatment, is that right?
Close enough to tertiary treatment.
So does it, is that treatment, good enough that you're seeing that you don't actually have a major outflow signal? Or how much are, if nutrients are elevated, by how much, and how far along the river before you get back to what you consider to be background? Does that happen or no?
So this is actually really interesting, because last year we started a project at Metro, and as far as nutrients go, Metro's outfall actually dilutes the river in nutrients. So the river comes in at really high, at much higher nutrients than the outfall. And that's because of all these processes that have been occurring at Metro over the years, where we had phosphorus recovery, nitrogen recovery. We've changed the way that we're doing basically like the chlorination process. There is no chlorination process at Metro. There's a prussiatic acid process because of the free chlorine could affect fish. So there's been like a bunch of stuff that, Metro Water Recovery in particular has been trying and attempting to, be just particularly good environmental stewards of the river, because we are the river, right? And this is what is happening in the river. And so so at the moment we are after this whole year, we are diluting the river as far as nutrient load goes.
Interesting. And then so those sites that come in, like Sand Creek and Clear Creek, which are potentially much more pollutant sources,
Right.
do you look at them chemically, is that right? Or do you also look at them biologically?
Right at this moment, we are looking at them chemically. Okay. So most of these sites, like Big Dry Creek and Clear Creek and Sand Creek, we take samples from those sites twice a month, part of our regular chemical readings. And then that's really important for us chemically. Now I'm trying to think about it biologically, because periphyton will have an influence with these confluences.
And what sort of things are in them? Are they high in nutrients or high in PAHs?
There's definitely high in nutrients depending on what day you're looking at. Some days they're even really high in DO or maybe pH. And it just depends on the time. I don't have all the data for that, but we can definitely talk about it later. if you'd like to, Sarah, just to see if we should, or if I should, add these three confluences into, the periphyton study.
Mhm. Yeah. Yeah, Leila.
How much cell of diatom do you have in general in your sample? Is it very abundant? Or?
So I haven't started. I haven't started. This is a project that is at the moment in funding mode. And this is me just talking about the potential that we are about to start this project. I'm not there yet, Leila. I'm sorry.
Oh, sorry.
No, it's okay. I promise maybe like 2 years from now, when Sarah has me back, I will have a good answer for you.
No, and my English is not very well, so I didn't follow everything. I thought that you already worked with your diatom, so that's why I was more interested about the ecology of the diatom than the assainissement of the waste in the
No, I
river.
understand. I understand completely. Maybe next time. Well, Sarah, I can only do a double presentation in English and Spanish. That's all I can do. I could definitely offer that.
That'd be great. You can give it again in Spanish.
And the photo is wonderful. It's very pretty.
Oh yes, this photo is my favorite site. It is in Julesburg, Colorado, which is really close to the Nebraska border. This is one of my favorite sites to go to. And this day in particular was really nice because you can see the chunks of ice going through the river. And I have only been in Colorado for 10 months and I've never seen snow. And I've never seen ice in water, and I was really excited about this area, but I was not excited about pulling up a bucket with half ice on it.
It's very pretty.
So really, your expectation might be that the South Platte below the Denver or Metro water recovery is going to be in pretty good shape.
Oh, I hope. Please tell me that. That would be amazing to report.
Yeah. Yeah. Well, I think we need to get out there and start looking at what the diatoms have to say about this river.
Yes, but not at 3-degree temperature. I totally agree with you, Anna, but not at 3 degrees, okay?
I also agree. I love a bucket of ice.
Right, of course. Are you guys working on Antarctica? Is that what's happening?
Yeah, there you go. Anna worked in the Arctic sea ice, and
yep.
I worked in Antarctic.
That's my thing.
I'll bring you.
There you go.
I'll bring you some next time, Anna. I'll try to keep it frozen, but it is an 8-hour drive back from Julesburg. Oh, that's really nice. Yeah, absolutely. I can't wait. I can't wait to get out there, and I'll hopefully have some preliminary, just some preliminary data. I'm hoping by spring. So we'll see how that goes.
Great. Well, Blanca, thank you so much for leading off our fall series of Diatom Web Academy. It's been really great to hear about your proposed project. And yes, we will have you back in a couple years to see how it turns out and what you find. And so thank you very much. And thanks to everyone for joining today. And we'll see you next time in 2 weeks.
Thanks, everybody. Have a wonderful day.
Bye.